Welcome to our deep dive into, well, the truly mind-bending world of quantum technology. Did you know 2025 is actually the International Year of Quantum Science and Technology? It feels like what was theory is suddenly very real.
It really is accelerating.
Yeah, and today we're looking at McKinsey's latest quantum technology monitor. It shows some pretty dramatic investment surges and faster innovation than may be expected.
That's right. The pace has definitely picked up.
So our mission today,
hmm
let's try to unpack what quantum technology, or QT, actually is, why this period, 2024-2025, seems like such a critical turning point, and this incredible market potential. I mean, they're talking nearly $100 billion in a decade.
It's a huge number and definitely worth exploring how we might get there.
Okay, so let's unpack that. We hear quantum technology, QT. What does that actually cover? What are the main pieces driving this massive potential?
Right. So QT isn't just one thing. Think of it as having three main pillars. First, you've got quantum computing. This is the one most people hear about, offering just unprecedented computational power, but for very specific complex problems.
Okay, computing.
Second, there's quantum communication. This is absolutely vital for securely transferring information. Think unhackable communication channels, essentially.
Unhackable, wow.
And third, quantum sensing. This allows for measurements with incredible precision, far beyond what classical sensors can do.
Sensing, right.
Yeah, and what's really remarkable is the scale when you put them together. McKinsey projects these three could generate up to, get this, $97 billion in revenue worldwide by 2035.
97 billion.
Yep, and quantum computing looks set to grab the biggest slice, maybe growing to as much as $72 billion itself. So, this isn't just academic anymore. It's a tangible, rapidly emerging market.
That kind of projection is staggering. But it really hinges on the tech working reliably, doesn't it? The report mentions this critical turning point in 2024, shifting from just making more quantum bits, qubits, to actually stabilizing them. Why is that specific step so fundamental?
That shift is absolutely key. It's not just a technical detail. It's basically the green light industries have been waiting for. Reliable qubits mean we can finally build systems that, actually complete complex calculations without constantly crashing or losing the information.
So it's about dependability.
Exactly. Remember, a qubit isn't just a 0 or 1. It can be both at once. That superposition gives quantum computers their power, but it also makes them incredibly fragile, highly sensitive to noise, temperature, any little disturbance.
Right, the fragility problem.
Stabilizing them means those delicate quantum states can persist long enough to do something useful, maybe hours instead of fractions of a second. And that reliability signal is what tells mission-critical sectors, finance, pharma, defense, that QT might soon be a stable, trustworthy part of their infrastructure.
And we're seeing money follow that stability.
Oh, definitely. We saw nearly $2 billion poured into QT startups globally just in 2024. That's a 50% jump from the year before.
Wow, 50%.
And governments are really stepping up too. Public funding now makes up about 34% of the total investment. Think of Australia putting $620 million into Sequantum for a utility-scale machine, or Japan's recent huge $7.4 billion commitment to the sector. They see the strategic importance.
So beyond the money, what specific technical breakthroughs are making this stability happen? You hear a lot about error correction. That seems like a massive hurdle. What's it actually solving?
It is a huge deal, yes. As you scale up the number of qubits, effective error correction goes from being like a nice-to-have to absolutely essential.
Why that?
Well, unlike the robust bits in your phone or laptop, these quantum states are incredibly delicate. They suffer from something called decoherence, basically. They lose their quantumness very easily because of noise from the environment. Error correction is like designing this really intricate self-checking system to protect those calculations, to catch and fix errors caused by decoherence before they ruin the result.
Okay, like a shield.
Kind of, yeah. A very active, intelligent shield. And companies like Google, with their Willow chip, they've shown significant progress. But you also have innovative startups like Alice and Bob, Atom Computing,